Okay, so what this section is going to be looking at is we're going to be looking at what probability is, which is basically the chance of something occurring given a certain situation. And that's what we're going to be looking at. It's very basic, simple probability. A little bit later, we'll be going over more complex, multiple events, but this is just straightforward, one event probability here. So the first thing is probability. So there's two different types of probability, theoretical and experimental. And so experimental is a probability where you take if you've watched something, you're going to take the number of times that something occurred and divide it by the number of trials that have been taken. So if I wanted to, let's say, flip a coin. So I wanted to flip a coin. I flipped a coin, 10 times. Okay. So I flipped a coin 10 times and 6 came up heads. I would say that the probability of flipping a heads was 6 out of 10. Okay, and that would be experimental because I actually did the process. I actually gathered the data and did it. That would be considered your experimental probability. Okay, so that's your experimental probability. You take the number of times that something, whatever the event is you wanted to occur, occurs over the total number of times you tried the process. Okay. And you'll either keep it in a fraction, make sure you reduce these fractions, so this would be 3/5, or you can put it as a decimal, 0.6, or percent. Okay. So percentage, just you take whatever the decimal is and multiply it by 100. Now, probability is between, if you want to keep it in decimal form, it's going to be between 0 and 1. Okay. It's going to be somewhere between there. You cannot have something be 110%. You cannot have something be -4%. Okay. If something has 0 probability, that means it's impossible to occur. It will never, ever, 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 ever occur. Okay. Now, if something is 100%, or the probability is 1, that means that it's always going to occur. Nothing else will occur besides that event. So this would be like if I were to flip a coin, what's the probability if it's going to be heads or tails? That's 100%. It's always going to be either heads or tails. It's not going to be, flower. That's not one of the choices in your in your coin. Okay, so it's just one. It's 100% probability is the highest you can have something. So when somebody say, oh, it's 110%, no, that's not possible. They're just exaggerating. So here's an example. So in a game, the USC quarterback completes 29 of his 30 passes of his 40 pass attempts. What is the experimental probability that a pass will be completed? So if we've done the experiment, he's thrown 40 passes, 29 of them were completed. What's the probability, experimental based, that the next one's going to be completed? We're going to have 29 over 40, and then that's going to equal our decimal and our percent. So it's about 72%. Again, you just do the number of completed over the total number of passes. Now, if we want to find how many were not completed, it would be the opposite, which would be 11. So 11 were not completed out of the 40, which ends up being about 0.275 or 27.5%. Now, if you were to add these two together, you see you get 100%. So the probability of something occurring plus the probability of something not occurring is always going to be 100% or 1. Okay. All right, sample space. So if you ever hear the word sample space, or they're asking what is the sample space, that is all possible outcomes. So thinking of a 6-sided die. A 6-sided die has 6 sides, obviously. And each side is a number 1 through 6. Okay. So your sample space, your sample space of rolling a die would be 1, 2, 3, 4, 5, 6. Okay, that would be your sample space. Okay, you have 6 different outcomes. 1, 2, 3, 4, 5, 6. All possible outcomes are part of your sample space. Okay. Now your theoretical probability is the probability of something occurring based on what the probability of something should be based on the information and not actually doing the process. So if I were to roll a die, okay, what is the probability of a even number coming up. Well, if we're looking at our six-sided die here, we've got 1, 2, 3. We've got 3 even numbers. So it'd be 3 out of 6, or 50%, or 0.5, 0.5, or 1/2. Okay. So your theoretical probability of it being even, okay, which all this p parenthesis, that just means the probability of whatever the event is. So the probability of it being even would be 50%. Okay, and that's theoretical. That's not what actually would happen. Now, if I roll the die 100 times, theoretically 50 should be even, 50 should be odd. But in real life, you might have 60 be even and 40 be odd. Okay, and that's something called it's based off normal distribution and the chance of something occurring and everything. So there is some error when you actually do the actual event, the experiment, but theoretically it would be 50. So if we did it long enough, it approaches 50%, the probability. So again, the probability of rolling an even number on a die, like I just said. Okay, so now geometric probability. So now that we've gone over theoretical and experimental, the last one is geometric. Now geometric probability takes into account area and volume and different things, actual objects, and it uses geometry. Now, let's say we have concentric circles, okay? Circles that share a common center. That's what concentric circles are. Now, my first circle has a radius of 1, okay? My second circle, the larger one, has a radius of, let's say, 8. Okay. So the smaller one has a radius of 1, the larger one has a radius of 8. What is the probability of me hitting the, let's say, the ring on the outside? Okay, I want to hit this. What's the probability of hitting this? So the first thing we have to do is that we have to do the probability of the total, or the area of the total, and then we want to go, and that's going to be the denominator, the top, or the numerator is going to be the area of the wanted, or the area of what we want. Now, since we're dealing with circles, we're going to be using the area formula for a circle, which is pi r squared. All right. And so the whole circle has a radius of 8. So that would mean that the total area would be 8 squared, which would be 60, which is 64. So the total area would be 64 pi. All right. Now the top one, or if we want just the outside one, that means we have to take out the middle. Well, the middle one has a radius of pi, or of 1, which means that it would be 1 pi. So the middle is 1 pi, and we're going to be taking it out of the 64 pi, which gets us 63 pi. Now the pi's cancel, leaving us with 63 over 64. So the probability of me hitting that ring would be 63 over 64. So again, you find the area of each one, circles, area, so you might have to review your area formulas, and then you put the area wanted over the area total. Right? And that's geometric. So geometric deals with area, volume, etc. All right, your IRAT. What you're going to do with your IRAT is, first, I want you to write 2 probability problems. Okay, do not use ones that you saw in this video. Please be creative. Okay, please make them simple probability. So it's one event occurring, not something that's like, okay, he pulls a red one and then a green one. We're not doing the multiple events yet. It's a single event. So something like, what's the probability of pulling, of rolling a die is perfect. There's other examples you can use. Just try to think about it. You can set up an example. So, you can say there's this many things in a box, etc., etc. So I need 2 of those. And then the other one, we've got 2 concentric circles, okay? One with a radii of 3 and one with a radius of 10 inches each. And I want you to find the probability of hitting the smaller circle. So what's the probability if we throw something at this, it's going to hit within the larger circle, but what's the probability of it hitting the smaller circle? Okay? And so that's what I want you to be working on for this one. Okay?